My dad told me to catch.
Oh, that's if you need to say that.
Yeah. That was just, I thought, oh, wait, stop, I said, he just said, it was surprising. I didn't actually. To be fair, that one really wasn't.
Yeah, that's right.
Hey guys, you can turn to page 26. There's a question about 10 and 11, so let me just walk through. Number 10 says going to Newton's law of cooling, the temperature of an object decreases at a rate proportional to the difference of this temperature and that of the surrounding air. So temperature is T, surrounding temperature is 10. I do like top 4,000. And it's directly related, so that's why K is the denominator, and this is the rate of change of T with respect to time. So big uppercase T is temperature and lowercase t is time. So that's part A. That's answer choice A here, and that is what we're going to use for number 11. So constant proportionality is K. You got the temperature minus the surrounding temperature. Okay, so that's what we're starting off with, number 11. Basically, we're just trying to solve this differential equation here. Okay, so when we solve a differential equation is we want to group the uppercase t's together on the left side, lowercase t on the right side. Confusing having the same letter for both the dependent and the independent variable. But yeah, uppercase t on the left, lowercase everything else on the right side. So dt over t minus 10, this is just like, imagine this was like y over y minus 10. We have to go through the substitution and natural log. On the right side, k is just a coefficient. So it's just really integral of 1 dt. Integral of 1 becomes t plus c. And so negative kt plus c. And then now that we're done with the calculus, now we're just trying to solve for uppercase t and then solve for c as well. So I decided that I wanted to solve for uppercase t first. So raise both sides with e as a base. Solve for t. I get ce to the negative kt plus 10. And now I have a set of order pairs that I can use to solve for my missing information. I know that at time 0, temperature 32 degrees, I can use that to solve for c. Once I solve for c, I update the equation. And now I have another order pair, 127. So at time 1 hour in, temperature is 27 degrees. I can use that to solve for k. So 1 goes in for t, 27 goes in for uppercase t. I solve for k. Once I solve for k, then I can create my uppercase t equation, 22e to the negative 0.258 t plus 10.
Are these temperature equations always going to go to the sum of CE to the KT or C negative?
Yeah, pretty much.
So I can just skip the differential equation. Or
not with this one because it's not, because that t minus 10 kind of throws things off a little bit. So it ends up being c to negative kt plus 10. I would still go through that this whole process. But you know, I think it's pretty unlikely that you're going to see something like this.
if it was negative, if it was just dt over dt equals negative KT, then
Yes, yeah, then I can skip it. Yeah, that t minus 10 though, I think it's just safer to go through the full separation of variables and solving it. Okay, so today we're going to continue working on unit packet 2A. And we're going to work through page 2736. So this is the last portion of AB content, which is differential equations and area volume. So I'd like for us to do this, though, if I can kind of walk us through this method, washer method, cross-section problem, just because we haven't seen it in a while. It's not hard, it's just, I want to make sure that, we still remember all the steps. So I'm gonna skip a few pages here. Actually, let's do this. I want to do one of these verifying with you, and then one, this method, washer method, and then and then you guys can start working on your own. Find one that we can do. Okay, let's do, how about page 27? 27, number 1. Let's see, number 0 here. Okay, it says the function e to the 3x minus 5x plus 7 is a solution to which of the following differential equations? So all of our answer choices has y double prime and y prime in it. And so let's just do some information gathering. Let's build out y prime and y double prime, and then see which one, after, if we can find our substitutions for these, see which one is going to end up being the true statement. Okay, so let's do that. Okay, what's y prime equal to? E to the u becomes what?
E to U.
Close.
Oh, 3e to the 3x.
Yeah. So e to the u times u prime, right? So e to the 3x times 3. And then 5x becomes, it's 5. Okay, y double prime. Second derivative. Yeah, so 3e to the 3x times 3, e to the u times u prime. We have another set of coefficient, and that's going to multiply with a 3 in front. So, and the 5 goes to a what? 0, right? So now we just have to kind of play with this and see, okay, and just test them, right? Which one is going to be the one that's going to work, right? I need to be able to replace y double prime with a number, replace y prime with a number, and then see if it actually ends up giving us 0. So let's just see what option A gives us. Y double prime is 9e to the 3x minus 3 times y prime minus 15. Let's see, does that equal to 0? Does that work? Is that a true statement? Yes. So this cancels out, this cancels out. Okay, so our first option worked, so there's no need to test the other ones. But that's the idea. With these verifying solutions, yeah, you're either using derivatives or integrals to match your answer choices. So you can see that with these problems here. Yeah, like problem number 4 on page 29, you're gonna have to find y double prime from y to see if you can get it down to solving for that equation. If you're thrown off by unknown constant like a k or an a or b, just treat it like how you would like a 3 or a 5, right? So, you know, if you ever get thrown off by strange letters, just pretend like that's a number and then treat it the way that you would treat a number. And then you can, and that may kind of help you kind of visualize what's happening with that constant, right? Sometimes we get thrown out by constant. So imagine that was just the 3 signed to the 5x. However way you treat a 3 is how you would however way you treat that 3 coefficient is how you would treat a k coefficient. All right, let me skip through a problem that I want to do with you. Okay, what about 35? 35, I think, kind of has a little bit of. Let's see, 35. Let me, no, let's just do 36. 36 has a little bit of everything in it. Let R be the region in the first quadrant bounded by the graph y equals 2 root x, the horizontal line y equals 6. So here's y equals 6, here's y equals 2 root x. And find the area of R. So if we're dealing with area, you can either do top minus bottom or right minus left, but typically I always say just try top minus bottom. That's usually the more efficient one, especially if the equation is given to you as a function. Let's just always start off with top minus bottom. So if we do area formula, it's just integral top minus bottom, and that's it. There's no squared, there's no pi r squared. That's the issue that some of my AP students were running into on their recent area volume quiz. They would do top minus bottom, and they would start squaring it because they're so used to this method and washer method. It just became second nature. So for part A, we just want to build our vertical rectangle here, and we're accumulating these rectangles from the left end to the right end, and it goes as far right as 9. And even if that 9 wasn't given to you and they give you the equation 6, you can kind of work backwards and say, well, I know that I want a y value of 6. I can just solve for solve for x. If I do 6 equals 2 root x, 6 divided by 2 is 3, 3 squared is 9. So we can still find that 9 even if it's not provided for us. As long as they give us that line y equals 6, we can find that 9. Okay, so top minus bottom. This is meant to be a non-calculator question here. So top is the 6. The bottom of my rectangle is sitting on the 2 root x. So 6 minus 2 root x. This is the height component. That's the width component. We're accumulating the area from the left region to the right. We can go through power rule for each of these terms, plugging up our lower bound, clean up all the way to 18. Okay, part B. Right, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So we can see y equals 7 is clearly off of the shaded region. There's a gap, there's a hole. And we know because of that rotation and there's a hole, there's going to be this method, our washer method. We need to draw 2 radius, one radius that extends from the axis to the furthest boundary, and one radius that extends from the axis to the closer boundary. Okay, so big radius is top minus bottom. The top is sitting at the 7. The bottom is sitting at the 2 root x. Small radius, top minus bottom. The top is sitting at the 7. The bottom is sitting at the 6. And again, we're accumulating these circular rings from the left to the right in terms of the x value. So from 0 to 6, sorry, 0 to 9. make sure that when you do washer method that you're squaring your radius independently of each other. You do big R squared minus little r squared. And it's just asking you for the setup.
Wait, why would this be washer instead of this?
Because the dotted line is not up against the flat surface. There's a gap. So if the dotted line was right up against the shaded region, then there's no gap, there's no hole. All we need is one radius. It'll just be this method.
So if it was over y equals 6, then
Yes.
you would use this.
This, yeah. So I want to also want to remind you that if the dotted line is touching the shaded region, that's not good enough. It needs to be up against a flat surface. So if it's only touching a point, there's still all this gap, right? So so for instance, if the axis of revolution was here at 0, this would still be washer method because even though it's touching, we still have all this hole, all this gap to worry about. This is still going to be washer method. Okay, part C. Oh, sorry, let me show the answer here. Okay, so big R squared minus little r squared from 0 to 9. This is the setup. If you want to go any further, technically you can work it out by hand, expand everything out, power rule, but they just ask for the setup. Okay, part C. Region R is the base of a solid for each y between the values of 0 and 6. The cross section of a solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base. Write but do not evaluate an integral expression that gives the volume of the solid. So this is neither this method nor washer method. This is going to be volume by cross section. But the first thing with cross section problems, we should always decide which orientation is our base going to be extended. Is our base length going to be horizontal or is it going to be vertical? And the problem will always tell you explicitly how to draw your base length. They say perpendicular to the y-axis. So which direction is that? Is that horizontal or vertical? Horizontal, right? Y-axis is vertical. You want something perpendicular to a vertical, so that's going to turn it horizontal. So you're going to build your base length horizontally. Anytime you see a horizontal anything, horizontal radius, horizontal height, horizontal base, you know you have to spend time rewriting your equation. The equation given to you is not in the proper form. It needs to look like x equals, and then the right side has to be in terms of y. So we have an equation here that was y equals 2 root x, or 2 root x equals y. How can I rewrite this equation so that it's suitable for a right minus left? X equals. So divide both sides by 2, square both sides, so x equals what? Y squared root 4. Sorry. And this side here, it's just part of the y-axis, so this has an equation of x equals what? Here. We'll build our base length first, right minus left. And now let's build our area component. So area of a rectangle is base times height. Now the problem will always have to give you information about the height. What did they say about the height? 3 times. 3 times the base. No, my base is y squared over 4, so it's going to be 3 times y squared over 4. So therefore, my area is base times height So what does that clean up to be? Area is what?
3y squared over 4 whole squared.
Mm-hmm. Which is 3y squared over 16, right? Now, once you have your area component built, that's really all there is to it, because the next step is volume. But volume, you're just going to put integral and dy notation and bookend it with that. You're not going to add any more parts to your formula. That is basically your formula. Okay. But what are our bounds going to be here?
0 to 9.
0 to 6, because y values, right? We want to find the lowest and highest y value. Whatever variable you're working with in your integrand is the variable that you want to apply for your bounds. There's no pi here, right? There's no circle related. The only circle related cross section is going to be semicircle, but that's pi over 8. Right? But here, volume is equal to the integral from 0 to 6, 3/16 y to the 4th. Okay. It's only asking for the setup, so any variation of this is good. Okay, last part. Write but do not evaluate an integral that gives the volume when the region R is rotated above the line x equals -1. Okay, so now x equals -1 is over here. Okay, disk or washer method.
Wash.
Yeah, there's a gap, right? It's not up against the flat surface. So we need two radius, one that's going to extend from the dotted line to the furthest boundary of our shaded region. That's big R. And then dotted line to the closer of the boundary, that's little r. We can reuse our equation that we've built before. So we know x is y squared over 4. We know this vertical line is x equals -1, and we know that y-axis is x equals 0. We build big radius, we build little radius, and then we do washer method just like how we did part B. And our bounds is from 0 to 6, just like part C.
So when finding the radius when subtracting, doesn't matter which order I subtract it.
It does, yeah. You want your big radius squared minus little radius squared. And then the way you can tell, if you put them next to each other, it should be pretty obvious. Big radius will be the longer one. Little radius will be the shorter one.
I get that, but like inside.
The inside actually doesn't matter.
Okay.
I'm always going to do right minus left or top minus bottom, just because that's how I did it with area. But because of the squared here, if you got these left and right mixed up, it won't matter, because that squared will turn it positive. But I'm always going to present it right minus left, just to let you know. Any questions? Okay, so we're gonna make progress. Page 27 and 36. I do want to point out that tomorrow we're going to shift over to packet 2B, but the solution key has both packet solutions in it. Okay, so. I can come up to get your phones. Tomorrow I'll check pages. Up to page 36.
Okay. First of all, we actually include because like the function of area. Feels like there's something like that. You come there. In your 74, so this. Yeah, that's why I didn't do that. Yeah, if you ever derive a rental, I would be as a, I said, you know, field rental, I was been in, finite, you got a lot of be, and here's the difference, but Oh, with the, well, use. But if you think. Like the field on video. Well, he used to have such. Thank you. Yeah, I figured it out. That's the only thing else. Yeah.
Good morning, Milton Eagles. When the bell rings, all sophomores, please report directly to the auditorium. Ninth, 11th, and 12th grades, please report to advisement. Thank you so much and have a good day.
You guys want to? Oh. It's not, right? I would just like to. Yeah, they were saying. We have to take her over. I caught myself. I feel. They want to take it. It's like a burden. Yeah. But my passion. So. Yeah. It's that's. It's a. Yeah. That's the budget. So I'm getting started. So like whatever you like, I just have it like spitting for it. Like lights in their task grade. Like I never like working inside everything. I actually like oh yeah. So it's just never the best because they make people are going to find it by this. Just know that it's big. What is it like by? It's a I said it like that. Okay, so not that. Yeah, they have like tomorrow. Like and I think we got over this topic. So they're like, oh, the drama. Like you probably go big conference. So it's too powerful. You will see it in the content. Yeah. They BC and then I did control. I mean, yeah, it's fine. But I just really have GT math here.
I'm reading, guys.
Guaranteed tech except.
I'm good today. I'm good actually. Okay, Vishnu, you have your homework or not yet? Oh, I'm almost, okay. Just send it to, you have sent it to me by tonight, otherwise it's all going towards the test, so I can tell less.
Yeah, yeah.
I mean, it's not a big deal, but.
How much am I getting?
At worst, it'll be 90%. Of the class. So.
45 of 50.
Okay, so I'm 2 days late.
Right, but I think, yeah, that's my thing. Just, they can just send it to me.
Yeah, I'll send it.
Yeah, send it by.
That's actually gonna take some.
Okay.
So, and that's you on.
Yeah, just send me one page at a time or email. Okay, either way.
Also, I'm going to a robotics competition on Thursday and Friday. So I'm
Tomorrow and Friday.
Yeah.
Okay.
So, I can slowly do your homework.
No. Well, I mean, if you're not here,
Yeah.
then I won't penalize you, but when you get back, just show us. Okay. That's fine. See ya. All right, thank you guys.
Yeah. Jeez.